Hi guys, if you are aware of recursion, then this question will teach you how you can go from a very least optimized code to the one that I was able to solve it. So we will be discussing a lot about this in question, but you should have a prerequisite of recursion. I'll try to explain in easy terms. You can see. So it's a medium level question, but like the understanding here is pretty far. So you can see like you will gain a 2D, I'll say array that will contain events. Like events of I will be also a vector which will contain start time, end time, and value. You will be given some kind of things like this. So it starts at the event 1 starts at 1 and ends at 3, and the value is 2. The maximum we are allowed, we can choose at most 2 non-overlapping events so that the sum of their values is maximized. We have to maximize the sum of the values. That's the question. So here this is given also in this way, like if you attended event with at time t, so you can choose another event at time t or t plus 1. So you can't be at 2 events at the same time. This is the basic, I can say, requirement also. So we'll start in this way. First of all, like first of the simple thing you can see is like the given input is 1 3. So starting from 1, it ending at 3, the value is 2. Starting from 4 to 5, like this 4 to 5, the value is 2, and starting from 2 to 4, this value is 3. So one of the simple thing you can do is, like I also recognize this in the question only. So if you decrease the value of everything by 1, like if you decrease the starting index by 1, it will be pretty easier. So also, like in the diagram you can see it starts from 1, but like we denote it from 0 to 3. It starts, the second value starts from 4, but we denote it from 3 to 5, and the third value 2 to 4 starts from 1 and ends at 4. So first of all, like a simple step would be that for each of the events, for each event you should do it this way, like decrease the events at index I at index 0 minus minus. So this will make it easier. Like if you want it, you can also do it in the question only, but by decreasing the value at the start will make it easier for the further discussion. Like for the simple example you can see in this. So now we can choose at most 2 events. So it would be better if we choose the event 0 and event 1, and we can get the maximum value 4. Similar for this case, here we should choose only event 2, and we will get the value 5, because if we can choose event 0 and event 1 also, but this will not help us in any way. It will give us the value 4 only. Similar case with this one. Similar case with the third example. You can choose events 0 and 2 here, event 0 and event 2 here, to get the maximum value of 3 plus 5. You will get the maximum sum of it. I think you can understand the question. You got the crux of the question now. So like this was the thing that I wanted to discuss. We will be discussing how we can optimize our code from the least solvable thing that you can think of as a recursion to the most optimized one. So let's have a look at this. This was my, I'll say, simple code, the one that I started with. The complexity was pretty poor. It was 2 to the power n, and the space complexity was O of n. So what I thought it, like first of all, was this one only. Like I basically decrease the value of each of the thing by like 1. So just for an easier calculation later on, this was the thing. I sorted them on the basis of starting time, so that we have at least one way to move. So starting events, I sorted them. Okay, so I'll make this function get max value. Like this is my original code, and this one is I have written like in a little cleaner way, and the comments are removed and the variable names are good. So if you want to understand, like this will be helpful. So we start in this way, like this. I call this function recursively. Let me call this function. I will pass the end time and the current index and the remaining events, and it should return me this function. I am believing, like this is the core concept of recursion. I believe this function, if I pass it the end time at any moment, the current index at any moment, and the remaining values, because we are allowed at most 2 values, so we should get back the maximum sum. So this is the one that we started with. So the current end time is 0, like it should be the value of the main function also. Current end time 0, current index is 0, and if I am starting with do, so this is the question only. So if I want to get the, if I get the value of this thing, I will be getting the value of what will be the maximum sum starting from 0, from t0 index, and remaining value is 2. So I think you can get this part. This thing is the main crux of the recursion. So these are the base cases. If the remaining events are 0, like if there are no remaining events in this array, like we can't choose any event, so what is the maximum sum we'll get? It will be 0 only, so I return 0. Also, if my current index at any time crosses index size, so it will be equal to, because of 0 based indexing, if current index at any time reaches event size, so we should also return 0. These are the base cases. So now we can start with this. We can start with the take value. Like we define a variable take value. So if we can take the value, we can take next index value only when our current index starting time is at index 0 is less than my current end time. This was the condition, like I can't be at the two events at the same time. So if my current index starting time is greater than or equal to, like suppose this was the case, these are the two events. If this is my current index starting time should be greater than or equal to my current, like my last end time, like the current end time that I had previously chosen. So then I can take this value. What will be the answer of this? Like take value would be, first of all, I'll add the value of this one. And also recursively call the function. Now my current end time will be the current index at value 1, this thing. My current index will be current index plus 1. I'll start from the next index, and my remaining events will decrease by 1. This is the simple take value thing. And now what is my skip value? If I'm at this index, I can choose to take or not take. If I take, then I can do this thing. If I'm not allowed to take, this can be in two way. Like either this condition gets false, then there is no option, I will have to skip the value. Also, like, but there can be case like I can choose to take this index, or I can not choose to take this index. So in that case, my skip value will be recursive function that I'll be calling with. Current end time will remain the same because I haven't chosen anything. Current index I will decrease because I want to skip this index, and remaining events will remain the same. And at last, I'll just say whatever be the maximum answer. I am at current index. Whatever be the maximum answer, if I choose that value, if I don't choose that value, return me this thing. So recursively, you can believe like this function will go on happening, and we will get the final answer here, because at any index we can at the maximum we can choose to take it or not to take it. So this also helps us with the time complexity. For each index, we are just choosing, we can take it, either take it or not take it. And we have already handled the condition, like my current index starting time should be greater than or equal to my end time of the last index that I was chosen. So this will directly help me in this case. There is no I'll say DP still involved. So for each index we'll be calculating based on these two conditions. So the time complexity will be 2 to the power n. So this will probably like automatically won't get submit. So then I move to the adding a DP layer to it, so that like the overlapping subproblems I'm able to solve. Then I move to the next index, optimization, I'll say. This was the thing that I did, and like it got memory limit exceeded. So what was different in this case? Like based on this simple recursive approach, I added a DP layer. What will be my DP state will be, because I can say the trick to add DP state is directly like you just see how in your recursive code what are the I'll say arguments that are changing. So in the last question only we can see, let me just clear all of these, and like if we just see which are the indexes that are being altered, then we can just store the value of these things and it will help us. So you can see this get max value will have something like this thing will change, my current index also change, my remaining index also change, like you can see similar with this thing. So these indexes, if we make a DP of first index, first argument, second argument, and third argument, we should be able to store we should be able to store the combination, and whenever this combination is called later on, we can just directly return value from the DP. So this will be our DP state. So what happened in this thing, it is the same code as like the same logic as previous. At each, this is my the core logic remain the same. The take value is this. I can choose to take value if my current index starting time is greater than or equal to my last event index at index 1 is the end time of the last event index that I chose. So now I started in this way, like I'll decrease the value of 1, I'll sort them just to sort by starting time so that we move in a fixed order. Okay, this will be my DP. What is the maximum value that last event index can take? It can be events.size plus, we can, for safe we can keep it 1 and 2 plus 1. What will be the current index? What is the maximum value that current index can take? It can be again events.size plus 1, and this last state is like remaining index. We can at most choose 2, so it will be like we can state 0, 1 and 2, so we can keep 3 value over here, and we'll initialize all of this with -1. So if it is not -1, this means like this state was previously found and we can just directly return this state. So we started with this thing. Now we just need to apply DP in our thing. So you can see take value, skip value, the logic remains the same. Just the thing is like in case of this, we directly returned the maximum of the take value or skip value, but in this case we can store this thing into our DP. Yeah, and like we will add this condition if at any time this DP state is not equal to -1, like the value was filled, like, or like we can say this was previously found not equal to -1, this means like this previously it was updated, so we'll just return this state. So now you can see this will basically increase our optimization a little bit. Yeah, and our timing complexity will now decrease based on this thing. You can see each DP state will be calculated like this. Each DP state will be calculated now, and we will be just doing for each DP state. This state can take value of, let's call our events.size as n. So we will calculate n states in here, n states in here, and 3 states in here. So time complexity will directly reduce to n square, like into 3. It's directly equal to n square. So this is our current time complexity, but you can see we will be storing each n our state in this thing. So but this time our memory complexity increases to, you can see, n 3n square. Again, this is our memory, but in the question it was given our events.size can be 10 to the power 5. This will directly hit our memory, like it will be around 10 to power 10, and we can't store it in a 3D array. So this will get me memory limit exceeded. So now we want to optimize at least the memory first, and then we can see if we can move to decreasing the time complexity also. So we move to our third approach now, third optimization I should say. In this approach we will discuss something different. Like I try to move it from 2 index, like using 2 DP states, the last end time and the current end time, to a single value. Let's see how we approach to this thing. So now, like these are the constant, like I'll decrease the value of each starting time by 1 and I'll sort it. I'll create here this time I just created a DP of single I can say single state, and the size of 3, like it will be 3 into n, the DP. And I again call the function of get max value. I'll just explain what these arguments are. So this get max value, I'll call it this recursive function, I should call it f. If I pass it the previous index, previous index, the number of remaining events, and like dp's thing, I'll make the function in this way. If I pass it the previous index, the number of remaining events, and then this function should return me, I believe, like this recursive function will give me the maximum sum, the thing that you wanted to return. So starting, like what will be our starting condition? Like at starting we don't have any I can say previous index, so we'll call it with -1. The number of remaining events we have is 2, and I'll call it dp. So this should be like, this is our final answer, this thing, and this is only what I have called here, this function with -1, 2 events and dp. So I think this recursive function definition is at least clear to you. So given a previous index, given number of remaining events, this function will return me the maximum value. Now we'll see how this function will be implemented. So this function get max value, like the base condition you can already determine. If the previous index, like we start with -1, so if the remaining events at any times get equal to 0, we return 0. This is the only base condition. Like previous index we can directly handle it in the for loop only. So this is the dp condition. If at any times we are able to find the value of previous index plus 1, like now I can also explain to you the case for why I use previous index plus 1. Because at starting you can see previous index is -1, so I'll keep each dp state as, I'll just increment by 1, I'll just shift each value by 1, because at the least the array index should be 0, and for -1 it will already return an out of bound exception. So we will just declare our dp state using this previous index plus 1. So that's why I have used event.size plus 2 here, not of event.size plus 1, because it's starting from -1 to n-1. There are n only, so it should be n plus 1 states, but while shifting each of 1, like I'll go from 0 to n. That's why we are keeping n plus 2 states here. So I guess you are able to get this. If at any time we are able to find this thing, this means like our dp was previously filled, this case was previously found, so we just return dp of this thing. Now the logic here is like, how do I move from 2 index to 1 index? So I'll make this function in this way. I'll make a new function like next value index. So given a previous index, so now I need to find what will be my next index. So you can see like we already sorted it. So one of the ways to find the just greater, like equal to or just greater than event from a last n time value, it would be like to simply use a binary search, because we already have a sorted array. So this function I created now. So this next value index, what it will do, it will take list of events and the previous index. What it should return me, this function, let me call it g, this function g should return me the first index after which we have the starting time is greater than equal to last time events, greater than equal to previous index. It will return, because we are already sorted, so it should return me the value, the index at which my starting time is greater than or equal to last event and time. Yeah, this thing. So this is a simple binary search you can do. So my, like the limits can be, the lowest I can go is like I can be at the same index only, so previous index, and the highest I can go is like total event size -1, this thing. And like this is a simple base condition. If I'm currently at -1, like there is no previous index as of now, so I should directly start with the 0th index, because this will be the first index where I'm able to meet this condition, like my starting time is greater than, because there was no previous event, so my starting time is I'll say greater than my last index. So this is a simple binary search approach, and we will return this thing. We'll believe this will always give us a correct answer. I should do this. This will always give us the next index where our starting time is greater than or equal to previous index n time. So this is the simple binary approach. It will take n log n time, binary search we can say. So now what I did, I'll call I'll call this variable best value. So this is not an still optimized approach, but we have decreased our space complexity. So what I did here, I started from I started my loop from start index. Like start index here is like the next index, like where there is no overlap. This is my start index. I'll keep on traversing till the n-1 event dot size -1. I'll keep on traversing here, and what I will check, like what is the maximum value. Like I started with this, I started with an event called best value. Currently it was 0. I'll need to find the maximum of the maximum of this thing plus what will happen if I chose those events, because after my start index is just the next index from where I can choose. After it, what are the indexes that I can look upon? Any of the index after start index is a correct index, so I can do it this way. I'll start from here and I'll just check, like from this case, what is the next best move, like, and then I move to next index, and then I again check for each element greater than start index. So you can directly see here, like from one index I'll calculate n-1 for n-2 for event. For index I equal to 1, I calculate n-2 states. So for each event I'm calculating the rest of the array starting from starting index. So this will give an approach of n square. This is the space complexity here. So our basic condition moves like this. So I'm currently at this previous index. I'll calculate the start index, like from where I can move upon, and I'll just choose the best value out of this index, plus I'll just pass it to the recursion. So now my previous index becomes I, because I'm starting from it. Remaining events decrease by 1. Events and DP are just arguments that we need to pass upon, and we'll just save this state in this DP before returning. So +1 is also understood. So you can see, like for each previous index I'll keep on calculating n-1, then n-2, then n-3. So it will be like, you can directly say n-1 plus n-2 is n square, n into n-1 by 2, almost n square time complexity. So now it solved our problem of memory limit exceeding, but we need to still solve for our time complexity, because this approach also gave me time limit exceeded here, you can see. So now you see the final optimization here. Now what I need to do, I still need to keep in single argument for my DP state to keep the space complexity lower, and I need to decrease my time complexity now. The main logic, the main flaw here in this approach is, like for each previous index I'm calculating for every other state that's coming afterwards. So now I can do it this way. I'll keep the next index function same. If I pass it an index, so it will return me what's the next index at which my start time is less than my current index end time. This is the basic again we can say binary approach, because it's sorted, so we can use this. So now what I did, I kept let me start with this here, get max value function here. So what it will do now, it will have an current index. Before, like in this previous approach we were using previous index, it will have current index. Remaining events still remain the same. The events and DP are simple arguments. What we'll do in this case, first of all, like our base condition will be like, if our remaining event is 0, so there is no other option, we need to return there is no, I can say, maximum sum if there is no remaining event, so we need to return 0. Now conditions occur for my current index also. If at any time my current index reaches to the end of the array, we need to return 0, because we can't choose anything here. Now this is our DP state only, is equal to -1, then we return this value. And what this function, like what will be the, I can say, return value of this function. I start from my current index is 0, remaining value is 2. So starting from this thing, this will return me the answer that we need to return. Like this is the starting condition. We at start we are at index 0 and the remaining values are 2 here. So this is the simple condition. Now the core logic of this recursive part is like, first of all, I find the next valid sequence. Like if I am at current index, I find the next valid I can say index, like where like this function will return me again what it will return, like the next index where my start time is less than my current index end time, just for non-overlapping. This is what we require. Okay, so now at this index I can take the current index or I can choose to skip the index. What will happen if I take the index? If I take the current index, so my value will be added by current index events at current index at index 2. Like this was our simple I can say given input, and then I calculate what will be, then I can, if suppose I've chosen this index, so what will be my next index? Next index will be the value returned by our binary function next index. This will be next valid index, remaining events will decrease by 1, and these are the just basic things required by the function. If at my current index I'm trying to skip it, what will happen? We will just calculate, because now it will be returning kind of 0 plus, we haven't chosen anything, so 0 plus get max value of current index plus 1, we haven't chosen it, so remaining events remain same, and events and dp. So now what happened in this case, for this index we calculated two things, take current and skip current. So take current will be directly, if we suppose chose to take this event, so this events at current index at index 2 will be our I can say value added, and then we can just recursively solve for the next valid index, and remaining index will decrease by 1, else we'll skip it. Like for skipping we don't get anything, so it will be 0 plus, and we will recursively call the function for next index, remaining event will remain the same, nothing decreasing. And at last what we will do, we will return the maximum of what will be the maximum output if we chose to take and chose to skip it, will be we will be storing it in the dp, and like the same condition, if at any time it is equal to -1, not equal to -1, then we return it. So this condition you can see. So now if you try to analyze the complexity here, what we are doing is, the first of all this will sort event will already take n log n. Now what we are doing, we are trying to fill our dp states, like we will be filling our dp state only one, and when we have found an, I can say, similar sub problem, we will just be returning. So it will be, this whole thing will now take only n, and the maximum part here also it's n log n. So the maximum time complexity it will take is n log n. So this is our final time complexity. Calculating this is pretty easy. Like for each index we calculate what will happen if we chose to take it and we chose to skip it. So I think this thing will directly store every possible state here. Yeah, so you can see like this approach, like we started from 2 to the power n, and space complexity we maximum reached n square also, and we are finally able to return at a value that's n log n in time complexity, and space complexity is only big of n only. So you can see this was the, I can say, my thinking and how I approached this problem in this way, and kept on optimizing till I got to the final answer. If there is any doubt, you can anyways write in the comment, and like just let me know. For if you like this kind of videos where I kind of try to illustrate what I thought and how I moved. So it's a pretty, I'll say, it's not for beginner friendly, but like you just need to be aware of how recursion works, and you can be able to solve this kind of problem. Yeah, see you in the next video. Thanks.